Hi guys, it's Miss Baker. Today we're going to go over page 201. What is the difference between mixtures and pure substances? Okay, so the first thing we have to do is we have to figure out how to classify matter. When scientists are asking themselves how to classify matter, they must ask themselves three questions. Number one, is matter uniform throughout? That means, does it look the same all the way through? Number two is, can it be separated by physical means? This simply means that you can take the pieces and separate them using tweezers or using your hands, some easy way to separate them. You are physically separating them. The third one is, can it be separated by chemical means? Meaning, do you have to do something that will make a chemical change in it to separate it? Okay, so the first thing we need to talk about is what a pure substance is. There are two basic pure substances that we're dealing with. Number one is an element. An element is chemically the simplest substance that cannot be broken down any further. Yes, it is made up by protons, neutrons, and electrons, but it must continue to maintain the properties of that element. All right. The second one is a compound. A compound is a combination of two or more different chemical elements held together by chemical bonds. The big deal between elements and compounds is that they are consistent. The big deal is that they are consistent. You don't have multiple different types of compounds together. You do not have multiple different types of elements that are not connected. Okay, the third thing we need to talk about is what is a mixture. A mixture is a combination of pure substances where the ratios are inconsistent. That means that there could be lots of one thing and less of the other, or just mixed up. Okay? There are two different types of mixtures that we're dealing with. We've got what's called a heterogeneous mixture and a homogeneous mixture. A homogeneous mixture means it all looks the same. All the materials look the same. Even though they're different pieces, that they all look the same. Heterogeneous mixtures is a mixture that looks like it is made of different pieces. Like in here, we've got peas and carrots. That is a heterogeneous. These things have different pieces. These all look the same. Okay. Is coffee a heterogeneous or a homogeneous mixture? Now, in this situation, that coffee is a homogeneous mixture. You've got the chemicals that make coffee, and you've got water in there. That is a mixture, and it all looks the same. The next one is oil and water. Can you see that there is a different materials in here? What looks to me like this is probably corn oil in regular water. It's very obviously different, so that is a heterogeneous mixture. This taco is also heterogeneous. It has meat, and it's got sour cream, and it's got lettuce, and it's got tomatoes, and it's got cheese, and it's got a corn tortilla. Those are all different things. They are obviously separate. They are obviously different, so that is heterogeneous. Okay, so this iced tea. If we're looking at the whole situation, you've got tea, you've got ice, and you have lemon. You can tell that these things are different, so that would be heterogeneous. But if you're just looking at the bottom part of that tea could be homogeneous. So you need to be very specific about what you are looking at. The next one is M&Ms. These M&Ms are in different colors. They've got red, brown, yellow, orange, blue, green, and yellow. These are all M&Ms, but they are different colors, so this is a heterogeneous mixture. So what I would like you to do on your assignment, the first page of your assignment, is for you to come up with your own list of mixtures. You may do this either using words or pictures. Okay, your assignment looks like this. You're going to come up with your own list of mixtures using pictures or words. Remember, you are to get pictures by going Insert, Image, search the web, and you can search for all sorts of different images here. You double click the image, it'll pop up here, you resize it, and then you drop it in either of these boxes. If you get more than what you really need, you can put them on either side. That is fine with me. Okay, heterogeneous solutions split into 3 categories based on particle size. They are a solution, a colloid, and a suspension. A solution is a mixture that has microscopic particle size and it will not settle. It allows light to pass straight through it. The particles are so small that it cannot be seen with a microscope. Our examples are soda, Kool-Aid, and salt water. A suspension is a mixture with large particles that will separate or settle out. You can shine a light through this material and the light scatters. It is a suspension. This is called the Tyndall Effect. Example, muddy water, oil, and vinegar salad dressing. I will show you this as a demo later. A colloid is a mixture with any particle size but does not settle. They are usually suspended in a medium. These examples are fog, mayonnaise, paint, and honey. You've got all sorts of colloids around. Like milk is a colloid if it already has the cream taken out, like the regular milk that you would get out of the grocery store. Now, if you have milk that is straight out of a cow, that is not a colloid. Okay, one of the demos that we're going to do in class is actually to make the colloid mayonnaise. Now, if you would like to try this at home, go ahead and follow this recipe. It's safe to do. It does taste different than what you are used to tasting on mayonnaise, but some people really like it. Okay, so I really like concept maps, so I'm going to show you how to decide the difference between each of these things, whether it be a solution, a suspension, or a colloid. So the first question is, will a light go through it? So I want you to imagine that you have a little tiny, strong flashlight, and you're going to put that flashlight against the material. So your question is, will the light go through it? If that answer is yes, then you need to ask yourself, does it settle? Settle means, will it separate after a while? If it will not settle, like Kool-Aid doesn't settle, milk from a grocery store doesn't settle, then it is, if it does settle, it is a suspension. If it does not settle, it is a solution. Now let's go back up where we're talking about will light go through it. If the answer is no, then it is a colloid. It should separate, but it doesn't. This is like that Italian dressing that doesn't ever separate versus does it settle? Yes. That would be regular Italian dressing. Okay? So that's how you try and figure that out. Okay, so the next thing I would like you to do is go back to your assignments, and I would like you to go to the second slide down, and this is 201 Poppy's mixture mark. So imagine that your grandma needs some things at the store, but the aisles at the store are labeled as solutions, colloids, and suspensions. You are going to pull the items over, look at the items over on this side. First of all, find the 3 definitions. And I need you to put these definitions under the correct aisle. Aisle 1 is solutions, aisle 2 is colloids, and aisle 3 is suspensions. Now remember, you need to go back to that concept map that was on the PowerPoint and figure out which is which. Then what you are going to do is simply pick this picture up and set it right where it's supposed to be. Okay? So, is butter a suspension? Is fog a colloid? I don't know. You need to look at that and try and figure it out. Okay? Okay. So I told you earlier that I was going to do a demo about the Tyndall Effect. And I am going to do a demo. Obviously, I can't do that under this situation, but I will do it when we are in class. So to tell if a material is a colloid, use the Tyndall Effect, the scattering of the light as the light beam passes through a colloid. So I'm going to have a variety of mayonnaise jars with materials in it. What we're going to do is we are going to take a laser and we are going to pass the laser light through the material. And you are going to look above the jars and you're going to see what the light looks like. So in this first glass cup, we have colloidal silver there. And the colloidal silver is a colloid, okay, called colloidal silver. Do you see how the light, you can actually see the laser going through there? Whereas the ultra pure water, which basically means it is water that has been captured as steam and made liquid again, which means it leaves all its impurities behind, or distilled water. When you put the laser through the distilled water, you can't see the laser. That is the Tyndall Effect, is whether you can see the laser passing through the material and it leaves behind a trail of light. Okay, I am going to leave you at this. You're going to do the mason jars. You're going to use Google Drawings, or you're going to use your... Sorry about that. My dog keeps trying to jump on me. You will use the rest of your assignment pages to show as well as you can what that laser is going to look like. Once you have completed this assignment, then you are to submit the assignment. I hope you guys have a good day. I will see you later. Bye. Bye.